Okay, so we come to the rules of differentiation. So from this subtopic on, we are going to differentiate all the function by using formula. Alright, so the first formula is about differentiate on constant function. A derivative of constant function. This is your first formula. So what is meant by constant? If you differentiate y with respect to x, when you see there is nothing x in the function, means this c is constant. Define for function x. Differentiate y with respect to x means you see for function x. Alright, so when you have constant, you differentiate, you get 0. For example, y equals to 7. You differentiate y with respect to x, you get 0. Alright, so dy dx, why we write dy dx? The differentiation of a function should be respect to the independent variable. If your y equation is in terms of x, that's why when we differentiate, we will write differentiate y with respect to x. Alright, so if your y equation is in terms of t, what's mean by in terms of that? Like y equals to x squared. So when you differentiate, you differentiate y with respect to x. Then use our rules to differentiate this quadratic. If your y is in terms of t, it will be differentiate y with respect to t. Alright, so to differentiate this, power move to the front, power minus 1. So the rules of differentiation is applied on the respecting unknown here. It will depend on what do you need here. If you respect to x, find for function x. If you respect to t, find for function t. So your t is in power, then power move to the front, power minus 1. So this is p by this. So what variable do you respecting on, then your symbol of differentiation will be writing according to that variable. Okay, then let's say you can see an example here, y equals to 2x. So we will differentiate y with respect to x. So we have dy dx. So when you differentiate this, the x is in terms of 2. So differentiate linear, you'll get constant. Every time in differentiation, your function will be downgrade. So from linear will become constant. Alright, from a x to the power of something, they will power move to the front, power minus 1. So formula number 2, to differentiate a x, or to differentiate a x to the power of any numbers. Alright, so the rules will be power move to the front, then power minus 1, ataupun power darab ke depan, then power tolak 1. Okay, 2 steps of differentiation. So for example, y in terms of x is in power 4. So we use formula number 2, independent x here, visit x here. So power move to the front, 4, power minus 1, x power of 4 will become x power of 3. Alright, that will be your second rule. Okay, sometimes we will get our equation in long term involving many terms here. So if your equation involving your terms by adding or minus, we can integrate, we can differentiate it one by one. So 5x squared, we differentiate one by one. Then 3x will be differentiate one by one independently. Alright, so no matter it's adding or subtraction of function, how long the equation will be, it will be integrate one follow another term continue. So when you differentiate this one, power move to the front, then power minus 1 become x. So for quadratic, you are downgrading your function after differentiation, you get linear. Then from linear 3x, when you differentiate, you will downgrade, you get 3. Alright, so this is some like the rules of differentiation. Alright, so if our y equation is no longer plus or minus in the term, they come out with multiply. So our y, and you look at the function here, our function x is multiplied with another function x. When you want to do this differentiation, we will use product rule. So this formula is called product rule. So how will be the product rule? Salin yang depan, differentiate yang belakang, tambah salin yang belakang, differentiate yang depan. So supposedly to be u dv dx, salin yang depan, copy the front function u, differentiate the v, so we get dv dx, plus copy the back one, function v, then differentiate the front one, you will get du dx. So it will be more suitable, follow the rules here. Although this is plus, it doesn't affect your answer, but our rules will come with copy the front one, differentiate the back. Alright, then plus copy the back function, differentiate the front one. So this is your product rule. And then if your function fx over gx, your function is in division order. Alright, plus minus order, no problem. Differentiate one by one, follow the order. But if you in multiplication, use product rule. If your x is in division, we use quotient rule. So how to do your quotient rule? Salin yang bawah, differentiate yang atas. The operation will be minus. Salin yang atas, differentiate yang bawah, and then divide by bawah square. So therefore we will have this formula. Copy the function at denominator v, differentiate the numerator du dx, minus copy the function up here u, differentiate the denominator dv dx, divide the denominator square, yang bawah ni square, become v square. Alright, so this is our rules. Alright, so yes, okay. You continue the derivative using chain rule or tower rule. So you can see y is in terms of u is in terms of x, y is not directly in terms of x, but you want to differentiate y with respect to x. So in order means that your y will be equals to gx into the new functions here. So your x, or maybe like this, any function gx in the power. Alright, so power rule, power move to the front. Oh, I start with bn first. Power darab ke depan, power tolak 1, differentiate dalam kurungan. So supposedly this is your SPM differentiation rule that you have been learned. This is rule number 3. From how you differentiate the constant, you get the first rule, differentiate constant, get 0. Alright. Second rule, differentiate a x, power darab depan, power tolak 1. Third one, your x is in another function. So your x is in the bracket of power something, you use power rule. So this power rule is directly already involve your chain rule inside. Okay, so power rule, power darab depan, power tolak 1, differentiate dalam kurungan. Then only we go for your product rule, formula number 4, quotient rule, formula number 5. In total, together with subtopic 9.3, we will have 9. We're going to have 9 formula to differentiate the function of the x. To differentiate whatever kind of the x, if you are respecting to x. Alright, to differentiate whatever of the x, like linear, quadratic, surd, log, exponential, trigo, any function. Okay? So for this 9.2, it's just your basic. Review back the 5 formula that you have learned before.